Hello everyone and welcome to the next video starting sequences and series. In preparation for this video, I've been studying up on some sequences and recognizing patterns. I'm pretty sure I'm a master at this point, and let's see if I can identify a few. That's the Fibonacci sequence. Oh, come on, that's just even numbers. That's a sequence of Euler numbers. Yeah, there we go. I think that pretty much proves I'm just a master of patterns. Let's get started. Wait, what's on my shirt? I don't know. This video will practice something called sigma notation, otherwise referred to as summation notation. Here, we'll take a sequence or pattern and summarize it into a formula. We also use this notation to sum up all the values inside of a pattern. The formula for summation notation, or sigma notation, uses this setup. The I at the bottom indicates where you start the pattern, and the n value at the top indicates where you stop. And what you're adding together is made up of the values in the formula for the x, which is where the typical element goes. For an example of what this looks like in action, we can see here, when you plug in 1, 2, 3, 4, or 5 for the n, you get 5 fractions, and each fraction is a representation of the result if you plug in 1, 2, 3, 4, or 5. And then you add up all those fractions and get your final answer. For your convenience, here are a few summation formulas that you may find helpful. In our first example here, we are going to attempt to expand and evaluate the sigma notation for k squared from 1 through 7. Because the expression says to do k squared for the numbers 1 through 7, we'll take k 1, 2, 3, 4, 5, 6, and 7 and square each of them. And then the rule for sigma notation is that we add all the values up together to get one final answer. When we add up the sequence, our final answer is 140. Here I am tasked with going back. I have a sum expression that I must write into summation notation. So I'm going to start with that sigma. I need to write my sigma notation so that it has 6 numbers. So I'm going to index my sigma notation from 1 to 6, and I need to write an expression that calculates out to each of these numbers, starting from -5 and counting down by 3. I'm going to use the expression -3n minus 2. That way, when I plug in 1, I get a first value of -5, and each number after that goes down by 3 because of the linear expression -3n. For each of these summation notation problems, I'll write out the start of the expression, but we should really consider a shortcut for each one. For this first one, it counts up k values from 1 to 80. So we would count 1 plus 2 plus 3. It's fortunate for us that this is an example of a linear sum, meaning that we could take this shortcut, taking n times n plus 1 over 2, and summarizing this answer into one value very quickly. Our answer is 3,280. In our second example here, we are adding either -1 or +1, but it alternates. So we are either going to be getting to a final answer of -1 or 0. If we were adding an even number of values, our final answer would be 0. If we were adding up an odd number of values, our final answer would be -1. So between 1 and 9, is there an even or odd number of values? There are 9 values, which is odd, so our final answer is -1. Instead of simply adding out to the end of the pattern, we can use this pattern recognition in order to jump to the conclusion when we understand what the numbers are going to do. To sum up our notes on summation notation, you start with your sigma notation, first value goes in, you plug in each number until the end value, you set up each expression, and you evaluate the sum to get one final result. Watch out for those quickly solvable patterns where you could jump to a conclusion based on the setup. I wish you the best of luck with this. Stay happy and healthy, and I'll see you in the next one. Bye!